When you go to a jewelry store, the last thing you're expecting is to find a corpse in your purchase. But if you're buying amber, that's a real risk. And I mean that literally. Pick up a piece of amber, and there's a chance, albeit small, that you're holding an ancient crime scene in your hand. Maybe it's a spider about to pounce on its prey, maybe it's termites caught in a prehistoric flash flood of tree gunk, or maybe, if you're really lucky, it's something nobody's ever seen before. Some bizarre creature that only was found because one day, millions of years ago, it zigged when it should have zagged. And before you ask, no, we cannot extract DNA from these things and make dinosaurs. I know, Jurassic Park lied to us, as despite DNA being relatively stable compared to other organic molecules, the oldest genetic material ever discovered was only from 2 million years ago, with a theoretical maximum lifespan of just 6.8 million years under absolutely perfect conditions. And so most amber is way older than that. I mean, the amber from the age of dinosaurs is pushing 66 million years at a minimum. So that DNA is about as intact as a snowball in hell. But here's the thing. What amber actually preserves is in some sense way more interesting than anything Hollywood came up with. We're talking about real snapshots of life from up to hundreds of millions of years ago. And this includes things that we never ever thought we'd find, going all the way from terrifying to absolutely groundbreaking scientifically. Now, you might be thinking amber is just fossilized tree sap, right? Well, if you are, that's wrong. Because it's not sap, it's instead resin. And that might sound pedantic, but there's actually a massive difference here. You see, sap is what flows through a tree like blood, so to speak, carrying nutrients up and down, while resin, on the other hand, is what oozes out when something goes wrong. It's basically the tree's emergency response system, and only certain trees have it, mainly conifers, but also some flowering plants. And here's how it works. When an insect drills into the bark, a branch snaps in a storm, or a fungus attacks, the tree starts pumping out this thick, sticky compound. And this stuff is loaded with chemicals called terpenes, which smell medicinal and taste somewhere between awful and straight up toxic. Which is exactly the point, as the resin is meant to seal wounds and drive off insects and microbes before they can do any more damage. So you can basically think of it as nature's combination of superglue, bug spray, and a tar trap rolled into one. But here's where things get interesting. When this resin drips down, it doesn't just disappear. As if the conditions are right, meaning it doesn't get washed away by rain, trampled by animals, or eaten by something brave enough to try it, it starts to harden. Because when the volatile compounds in it evaporate, the remaining molecules link together in longer and longer chemical chains, making it stable. And if given enough time, and by enough, I mean at least tens of thousands of years, and then combined with pressure from the sediment above, which has now buried it, and heat from below, this one sticky tree defense becomes something incredibly strong, fossilized resin, also known as amber. And calling this stuff tough is the understatement of the century, as it can survive for hundreds of millions of years without breaking down, which is why we have amber from the Carboniferous period, despite it occurring 300 million years ago. So to put that into perspective, we have amber that's not only older than flowers and dinosaurs, but also the literal Atlantic Ocean. And so, unsurprisingly, with an existence this long, amber isn't exactly rare, with major deposits having been found all over the world, with each location telling its own story. For instance, the Baltic region is famous for its amber that's about 45 million years old. The Dominican Republic has amber mainly from around 15 to 20 million years ago. And then Myanmar has deposits that are roughly 100 million years old, right from the middle of the Cretaceous. And the oldest piece of amber ever found? Well, that came from Illinois and was dated to 320 million years ago, back when the biggest predators on land were giant amphibians and millipedes longer than Shaq is tall. However, that being said, the oldest amber with actual creatures trapped inside doesn't show up until a bit later, with the earliest found thus far having come from late Triassic Italy, dating to around 230 million years ago, meaning around the same time as the first dinosaurs. And I know what you're thinking. What incredible prehistoric monster did they find? Well, drumroll please, it was mites. Mites and a fly. But wait, before you sigh in disappointment, let me explain why these aren't just any mites and fly. The mites are extinct 230 million year old specimens named Triassicaris fidele and Amphizoa triassica, while the fly was a nematoceran, meaning it might have been a distant ancestor to mosquitoes. Which also just goes to say that even hundreds of millions of years ago, nature was already working on ways to ruin the outdoors. Now, the reason the fly has no name is because it was very poorly preserved, but the mites, incredibly preserved, despite being only 0.2 millimeters or 1/128th of an inch. In other words, smaller than a pinhead. And yet, even with their tiny sizes, we can still make out incredible detail, not just their segmented bodies, but even the fine annuli encircling their abdomens, the structure of their mouth parts, and the delicate feather claws in their legs. Which is kind of crazy when you think about it. Here we are, looking at a 200 million year old tiny creature, and yet, we can still see the individual leg structures on it. But you might be wondering, how does something so small manage to get trapped in resin drops in the first place? But think about it from their perspective. A single drop from the tree would have been like having an Olympic swimming pool filled with honey dumped on your head. So the chance of escape was, pretty low. But because of this incredible preservation, scientists could also immediately identify them as specifically gall mites, those little bastards that cause weird growths on leaves. And despite being separated by over 200 million years from their modern descendants, many of the distinguishing features of this family were already there. The long segmented body, only having 2 pairs of legs instead of the usual 4 found in other mites, unique feather claws, and specialized mouth parts. And it's only because of Amber's incredible abilities that we can figure this out, which is really what makes Amber so special compared to regular fossils. As when an animal fossilizes the normal way, usually only the hard parts survive, with soft tissue impressions being rare, and actual soft tissue almost never. But Amber is different, as it not only preserves soft tissue, but also does so in ridiculous detail. I mean, we're talking about muscle fibers, internal organs, and sometimes even individual cells. So it's kind of like the difference between finding a skeleton and finding a mummy, except honestly, even better. Now, while 200 million year old insects the size of sand grains are scientifically cool, I'll admit they're not exactly riveting. But if we fast forward about 130 million years to the Cretaceous period, that's when we start to find the really interesting stuff, as the world back then was not only hot, humid, and covered in forests, but it also had dinosaurs everywhere. And here's something that people still get wrong, which is that they often picture dinosaurs as those scaly monsters from the original Jurassic Park. And while some certainly could have looked like that, many did not, instead having feathers. And paleontologists have known this for a while, based on both evolutionary relationships and fossil impressions. But knowing something and seeing it are two completely different things. And in 2016, researchers discovered an amazing find. A piece of Burmese amber that was about the same size of a dried apricot. But while the size wasn't exactly impressive, the same can certainly not be said for what was found inside it, as inside held something paleontologists could only have dreamt in their most exciting of dreams. A dinosaur tail. Not a fossilized tail, not even an impression of a tail, but rather an actual tail with skin and feathers still attached. And obviously, this is an absolutely incredible find. And so of course, like any good researchers, they try to figure out a way to see inside it without actually breaking it open and damaging the specimen. And the answer was micro-CT scanning, a method that uses a ton of radiation to find very fine and precise structure detail. So perfect for dead things, and not so much for living things. And what they've found even surpassed their greatest expectations, as not only did it contain 8 vertebrae still connected, but they were also able to make out that the feathers had barbs and barbules, the tiny hooks that zip feathers together, with them also making the important distinction of there only being a weakly defined rachis. And this is important because what this means is that these were no stiff aerodynamic flight feathers, instead being feathers more suited to ornamental display than any sort of flight or gliding. And so using both the feather and bone structures, they were able to deduce that this belonged to a juvenile non-avian coelurosaur, in other words, a small theropod, which was likely about the size of a sparrow at the time of its death. And chemical analysis revealed even further details, finding that there were still traces of iron where blood cells would have been, meaning the tail could possibly still have been bleeding when the resin engulfed it. Possibly. And what's crazy about all of this is that this isn't even the only piece of amber we've found with feathers, as others have been discovered containing different isolated feathers with intact melanosomes, the tiny structures that create colors. And by looking at them, scientists could tell that some feathers were brown, others black, others white, and some mottled. And then just as a cherry on top, another amber feather specimen was even preserved with a tick on its feather, meaning that even 100 million years ago, dinosaurs still had to deal with a hellspawn known as ticks. Some things never change. But speaking of stiff, that's basically how my back feels after spending hours researching these specimens. So when FlexiSpot reached out, offering to let me try their C7 Max chair, I figured, why not? Seeing that my old chair was essentially leading me to early fossilization. And honestly, the difference is pretty significant. The lumbar support actually supports both your lower back and sacrum, which apparently matters more than I thought. And the whole backrest adjusts to whatever height you are, the headrest tilts in 3 dimensions, and the armrests move in 5 different ways. In other words, lots of options. Plus, the seat itself has this latex seat cushion with memory foam that helps with those 12-hour research sessions. And then perhaps my favorite part is the fact that there's even a footrest that you can pop out, which frankly I've never even seen before in an office chair. And then just as a cherry on top, they give you a 30-day return policy and a 10-year warranty in case something breaks. However, I can report that while I've just started using this chair, I do have a FlexiSpot desk which I've used for quite a while, and it's held up great. So if you're interested, use code C730 for $30 off on either the C7 or C5 chair. Links in the description and comments. And now, back to the video. But one thing to keep in mind is that amber doesn't just capture animals, it captures anything around it, including, well, plants getting it on, so to speak. You see, one piece of amber found contained a bouquet of tiny flowers, each smaller than a rice grain. But these weren't just any flowers, they were flowers caught in the act of being pollinated. Scandalous, I know. The flowers, now named Micropotassos burmensis, had pollen grains stuck to their stigmas, the female parts of the flower. And what's crazy is that the detail was so well preserved that you could see the beginning of pollen tubes growing down towards the ovaries, with these tubes being how flowering plants deliver sperm to eggs. And here they were, frozen mid-deed 99 million years ago, being one of the oldest visible examples of plant reproduction, and probably plant erotica too. And it gets better, as the pollen grains were also likely coated in a sticky substance, likely the same, if not similar, to the modern pollen kit, which is designed to stick to insects. Meaning that scientists were able to strongly infer that by the mid-Cretaceous, flowers weren't just relying on wind for pollination, they were already in cahoots with bugs. And speaking of bugs, one of the most mind-blowing amber finds was a beetle with a built-in flashlight. But not just any beetle, a nearly 100-million-year-old beetle named Cretophagotus azari, and it was found still carrying its photic organ. In other words, an ancient flashlight built right into its butt. But unlike fireflies who use their glow for communication and mating signals, scientists think this beetle's glow originally evolved in larvae as a warning signal. Basically a, I taste terrible, don't eat me sign. Though knowing how fish and birds react to shiny things, I'm not exactly sure how effective that was. But regardless, what this means from the bigger picture is that while tyrannosaurs were stomping around being all terrible lizard-like, Cretaceous forests were already twinkling with living lights, just like many forests today. And again, similar to today, the forests back then were also filled with tiny reptiles and amphibians, not just the giant animals we typically associate with this time. But these are often overlooked, not only because of their size, but also due to the problem of smaller animals fossilizing at much lower rates than larger ones, due to their bones being more fragile, the fact that they're more wholly eaten, etc. However, amber doesn't care about size. As long as it covers something, it's golden, no pun intended. So because of that, we've been able to find amber with tiny reptiles and amphibians that would normally never survive fossilization. Take geckos, for instance. One Burmese amber specimen preserved a gecko so perfectly intact that you could see not only the tiny structures on its toe pads, but also what appears to be the microscopic setae, the same van der Waals force-powered equipment that lets modern geckos run up your walls and ceilings like Spider-Pig. And not only that, but scientists also found what looked to be a baby chameleon in amber as well, which would be the oldest chameleon ever found. It had the right body shape, the tail, and even what looked like the beginnings of those large crazy eyes. I mean, researchers were basically one phone call away from announcing to the world that they found the earliest chameleon ever. Until that is, they did a CT scan on the amber. Because, as it turns out, not only was this not a chameleon, it wasn't even a lizard at all, instead being something we had never seen before, a species now called Yaksha pareti, which turned out to be a part of an extinct group of amphibians named Albanzerptontid. And the reason we're able to figure out this was due to the CT scan revealing a skull structure that was just all kinds of wrong for a reptile. But here's the kicker, even though the skull was off, the other structures are remarkably similar, as mentioned, with this guy even having a ballistic tongue, just like a chameleon. And this is convergent evolution at its finest, two completely unrelated animals evolving the same solution to the same problem, with them both needing to catch fast-moving prey in likely similar environments. And so the answer was a spring-loaded tongue. Now, I mentioned that small animals generally don't fossilize well, and this is true, but there's one specific type that fossilizes even worse than normal: baby animals. And this makes a lot of sense when you think about it, as not only are they tiny, but their bones also haven't fully mineralized, something which regular fossilization usually requires. But, like we've established, amber does not discriminate. It will absolutely trap anything that it can grab. And so one piece was found containing a snake so young that it was probably fresh from the egg, a species now known as Xiophis myanmarensis. And at less than 5 centimeters long, it was smaller than your pinky finger. But despite its small size, in typical amber fashion, the preservation was remarkable, with scientists finding 97 vertebrae and unfused bones in the specimen, which also confirmed that this was indeed a newborn. and another piece of amber from the same area contained a shed snakeskin with perfectly preserved scale patterns, which together proved two things. One, that early snakes were already adapted to forest life, and two, that they were more widespread than we first thought. And so these finds might not seem very remarkable, but they did actually help fill a massive gap in our understanding of snake evolution. As before this, we had ancient snakes from Gondwana and more modern snakes in Asia, but basically nothing in between in the area where this was found. And so these amber babies gave proof to how snakes spread and diversified as the continents drifted apart. And speaking of babies, if you think giving birth is tough now, imagine doing it while drowning in tree resin, as that's exactly what happened to Cretatortilosa gignans, a land snail preserved at possibly the worst moment imaginable. This snail, only 11 millimeters tall, i.e. about the size of a button, was caught with 5 newborn babies, one even still being attached. And unsurprisingly, her tentacles were extended like she had just realized that something was wrong. Very wrong. And yeah, there was. You see, this poor mother had just survived childbirth, only to be buried alive by tree goo. Talk about going from the miracle of life to the tragedy of death in record time. But besides capturing what has to be one of the most terrible deaths imaginable, this fossil also showed something scientifically important, which is that some snails were already doing live birth 99 million years ago, keeping the babies inside until they are birthed, instead of laying eggs like most other gastropods. And this wasn't the only snail evolutionary quirk captured by amber, as another specimen, known as Archaeocyclotis revivilosus, was preserved with what looks like tiny hairs all over its shell, with each hair being only 150 to 200 micrometers long, but still clearly visible in the amber. And while this is a now extinct quirk, scientists do think these certainly played a very real function, potentially being designed to help with traction on wet leaves, or camouflage, thermoregulation, or perhaps just as some sort of display for sexual selection. However, with that said, beyond just pure scientific value, amber also captures moments and things that are just, well, cool. Perhaps best exemplified by a 100-million-year-old amber that had a spider and wasp showdown that would make any modern action movie jealous. The spider, Geratinophila bermanica, was a juvenile orb weaver caught mid-attack on a wasp called Cascocelio incassis. And so considering the participants involved, needless to say, we're rooting for the spider. And I am happy to report that the wasp was clearly on the way out, being entangled in silk, while the spider itself was just preparing to bite and eat its prey. And funnily enough, a second male spider lurked nearby, perhaps as backup or just as a front row seat to the show. But what's really interesting, and also kind of creepy, is the fact that these wasps were parasitic, actually being part of a group known to lay their eggs inside spider egg sacs, so that their babies can then eat the spider babies. Gruesome, I know. And so, I like to think of this spider as getting revenge on behalf of all of its kind, maybe even on behalf of its brothers and sisters. But regardless of this potential drama, this piece also represents the only known fossil of a spider attacking its prey in its web. But not all amber fossils are this dramatic. Some are just awkward. Take Halithroses grimaldi, a harvestman and relative of Daddy Longlegs, which was preserved with its penis fully extended and ready to go. And what's crazy, and also probably very embarrassing for our friend here, is that the preservation was so detailed that scientists actually used its genital structure to classify it into a specific family, which is honestly insane when you think about it. I mean, imagine dying butt naked, only for scientists millions of years later to use the shape of your permanently exposed genitals as the way to determine which species you belong to. Yeah. And while we don't know if it died mid-mating, or was just trying to impress someone, one thing is definitely for certain, which is that this has to be the most embarrassing fossil ever found. But hey, I'll take embarrassing over terrifying pretty much any day, and this includes one of the scariest amber finds ever, which doesn't actually show a predator, as one might think, but instead, a tiny flea. You see, what they found was a 20-million-year-old amber piece with a flea so weird that scientists literally named it the strange flea in Greek, Atopopsilis sionis. But that is not the scary part. Rather, it's the clusters of bacteria around its mouth and rear end. And while it might not be surprising to find bacteria in these two locations, the problem is that these bacteria shared a scarily similar presentation as to what's seen in the bacteria responsible for the plague, i.e. that pesky thing which wiped out nearly 50% of Europe's population. And if these really were ancient Yersinia bacteria, then it means that some form of disease might have been killing mammals millions of years before humans even existed, and thus making the Black Death just one small chapter in a bacteria that might have been wiping out our relatives for millions upon millions of years. So, with all this said, you might be wondering, beyond being cool and somewhat scientifically interesting, why do we care so much about things trapped in old tree gunk? And the answer is actually kind of self-explanatory by this point, which is that it gives us a very clear picture into the past, allowing amber to both fill gaps in our understanding, as well as prove things that could only have logically been assumed prior, and often in a way that regular fossils simply can't match. Take flowers, for example. We know the evolution of flowering plants changed the entire planet, but we have gaps in understanding as flowers rarely fossilize. But here we have a piece of amber not only capturing some of them, but also capturing them mid-pollination, showing us reproduction from millions of years ago in real time, so to speak. So while Jurassic Park fans might be disappointed to hear that there's a 0% chance of us using amber to bring back dinosaurs, I think it's better to reframe it. Amber isn't a potential blueprint for resurrection, but it is basically life itself, frozen in action, which is honestly just as cool, if not more so. And here's the thing that really gets me. Somewhere out there, in deposits we haven't found yet, there are pieces of amber holding secrets we probably can't even imagine. I mean, we've found amber with literal dinosaur tails and snails giving birth. So who's to say what's really out there? Because occasionally, when conditions are just right, a tree bleeds on something interesting and we get to see it forever. Thanks for watching, and until next time on ExtinctZoo.